Good morning, everybody. This is Mustafa Sözbilir from Atatürk University in Turkey. And I would like to start with thanking to the conference organizers for inviting me and letting me a chance to talk about to you this morning. And I would like to start with giving brief information about myself. I'm a professor of chemistry education working in chemistry teacher training department. And in the last more than 5 years, I'm working on teaching science to visually impaired students as well on this study. And then I have some collaboration with people around the world, including Professor Daniel Cha from the Daegu University too. So today I will talk about my research in teaching science to visually impaired students, and I would like to summarize with some of the problems that we are facing during COVID-19 pandemic. You can see the outline of my presentation here. I will give you a brief information about impairments and teaching science to visually impaired students, and then I will switch quickly to my research and then give some of the research results and summarize it with the conclusions. As everybody else, I guess, in this meeting knows about the impairments and disability terms, I'm not going to give into the detailed information on this one, but the impairments are the problems in body functions or alterations in body structures such as blindness or deafness or other kinds of problems. On the other hand, disability is defined as the loss or limitation of opportunities to take part in society on an equal level with others due to the social and environmental barriers. In this sense, the disability is actually created by the society, not just by the person, not by the impairments. So the World Health Organization states that disability is not an attribute of the person, but inaccessible environment creates this disability by creating barriers to participation and inclusion. So it is actually something that's done by the society due to the people's impairments. Visual impairments, also known as the vision impairment or vision loss, is a decreased ability to see to a degree that causes problems not fixable by usual means, such as glasses or other helps. On the other hand, blind refers to individuals with no vision or only light perception. So the impairments, visual impairments, is a much more general term. The blind people or the low vision people also covered inside the visual impairment term in general. How about teaching science to the visually impaired students? The current research is, when you look for the literature, current research is mostly focusing on instructional design and adaptation of the available methods and instructional materials, the instructional material developments and ICT integration and studies on affective dimensions. There's not many research on teaching science to the visually impaired students in general, if you compare with the other parts of the science education research. But in the recent years, in the last 4 or 5 years, there are too many researchers also coming out of in this area too. Students, on the other hand, blind students or low vision students, if you compare with the sighted peers, they have to follow the same curricula and they have to learn every topic that the sighted peers has to learn. But they have so many disadvantages if you compare with their sighted peers. The resources and the instructional methods are not mainly based on are mainly based on the vision, but the materials are hardly accessible by the blind students or the low vision students. So the problem is actually in teaching and learning science. They have to learn what their sighted peers has to learn, but they have not equal access or equal opportunities in terms of the accessing to the learning materials. So what is the solution? The problem is the accessibility problem. What is the solution? The solution is actually to make the materials, everything else, what you are doing is accessible in terms of what you can do, some kind of by modification, by adaptation or intervention of the educational resources, or on also the methods that you are using in the instructional process for the needs of the visually impaired students. So what we need to do, we need to understand first the visually impaired student needs, and then try to modificate what we already have available in our hand, or also adaptate the materials or the instructional system, or develop some kind of interventions that would help to visually impaired students in learning science. So when we come to our research, what we did in our research, basically, we start with broad questions like, what are the needs of the students with visual impairment in learning concepts, in learning the concepts and skills relevant to the science? Because the science has some distinct features, distinct features separating from the other subjects. So what are the basic needs, the special needs that the students need learning science concepts and science skills? So on the other hand, we wondered about, can we teach effectively basic science concepts and critical thinking skills and scientific process skills to these visually impaired students? If the answer is yes, then which methods or what kind of adaptation or on the materials and the methods that we can use in teaching, and it could be effective in delivering science? So we started with these three broad questions, and then we came down to our research questions, which I'm going to talk about today. This study is a very large study, but I'm just going to talk about two questions on it. What are the needs of the students with BLV, which is blindness and low vision in learning science, and how these needs could be met in designing instructional materials and instructional activities? We started with a need analysis first, and then based on this needs analysis, we designed and developed some instructional materials and instructional activities. And also we implemented these materials and activities and evaluated whether they are working or not. In the process, in terms of the instructional design, we followed the ADDIE model, which is a most commonly used basic instructional design model. In terms of the research aspect, we employed the design-based research approach. Need analysis actually carried out with observation and interviews, as well as the curriculum analysis. We initiated with the analyzing of the curriculums, what kind of concepts needs to be taught, and then what kind of skills need to be developed, and then we focused on this, and then we went into the classroom and then observed the children while they're learning in the classroom, what kind of needs they need, and also we interviewed teachers and the students too. These observations that we did actually was an unstructured observation, which is we just sat down inside the classroom and then start observing everything else, what kind of things are happening inside the classroom. And on the one side, and also we recorded the classroom. Because one of the researchers was sitting inside the classroom and then actually observing the classroom, and on the other hand, we were also recording the classroom to do a further analysis together with as a research group in our city, which is Erzurum in Turkey. This was a middle school, which can be counted as a lower secondary school. The analysis, the observation actually took place in the 6th grade and the 8th grade. In the 6th grade, there were 6 students, 1 blind, 5 low vision students. On the 8th grade, there were 5 students, 3 blind and 2 low vision students, and one of the students was also congenitally blind. So there was quite a variety of differences in terms of the students' visual capacities. We worked 2 different teachers. In the needs analysis stage, we worked with a female teacher with more than 10 years of experience in science teaching, but only less than 3 years of experience working with the visually impaired students. In the implication stage, we worked with a male teacher, which is a temporary replacement teacher with no teaching experience. It was the first time for him that he was teaching in the visually impaired students' classroom, as well as he was a new teacher. He was no experience with the teaching also. So none of the teachers also has no training for teaching students with the BLV or the visually impaired students. The topics that covered in the science, there were 3 different areas, like one of them is life sciences, which is biology, matter and change, which is chemistry, and the physical phenomenon, which could be counted as physics. The findings showed us that there were the main problem in the classroom, that the teaching was based on lecturing, not much adaptation or materials or instructional settings. Some of the adaptations that they did it based on just the experience, not based on the research. On the other hand, one of the main problem was the teachers' lack of knowledge in teaching science to students at BLV, and also the lack of the facilities. Teachers basically did just a demonstration in many cases in the classroom, but the blind students were excluded. They cannot include it. Print materials were not enough and not available in Braille in many cases. Students mostly were passive, no active participation to the practical works to develop practical skills. And when we interviewed them, they said science is one of the most boring subjects. We don't like science because we cannot participate in it. And also the basic needs were materials and hands-on activities designed carefully to meet their needs, particular needs. So we took these results to focus on developing instructional materials. What we did, we tried to develop tactile materials first, and also we adapted these tactile materials in 2 ways to the needs of the students, because the teachers don't know about the Braille, so it was really necessary to print the materials with the normal text as well as the Braille printing. And this was also helpful for the parents as well, because we developed these instructional materials and everything for each individual students, and the students were able to take these materials to their home to study extra whenever they want in their houses. And then it was important to show that it has to be printed as well in the normal text, otherwise their parents and cannot help students what is written in this kind of materials. As you see here, we also printed some of the pictures or the diagrams with colorful pictures as well, also the tactile structure, so students can see and work on them. And also for the low vision students, we developed these tactile materials also with large fonts, expanded large fonts, so that they can also read what else written on them. We use the color as well. This color also is helpful for the low vision students, but also helpful for the teachers and also the parents to help their kids to teach about themselves. You can see here the 2 different versions of the same material, which is produced on the left-hand side, the same material, which is enlarged prints. On the right-hand side, the normal text printed on it, and also the Braille printing on the same material. You can see the different versions. On the right-hand side one, you can see the diagrams, which is also highlighted. These diagrams are printed with a printer which is called embosser printer. It can also print everything else. You have the drawings on this one. And the left one is suitable for the low vision students. Right-hand one is suitable for the blind students. We didn't give the low vision students the braille printed materials because it makes hard for them to read the normal text. We also used everyday materials and also the 3D technology to print them together, some of the materials you can see here. We also adapted some of the materials available in our hands with the plastics, and we also designed some of them 3D, and then we printed with the 3D printer and then put them together. And then you can see here the flowering plant's life cycle as a whole. You can see here there are some everyday materials and also the 3D printed materials, and also it is fixed onto a board, and then the color differences with the light color to help the students to see here. You can see also here more materials like the female and male productive system of the human. This is the similar idea applied to the vegetative reproduction system. And also this one is also very important. These are the life cycles of a frog, which is produced by 3D, designed in 3D and then produced by the 3D printer. And then the eggs here is just a normal material you can find from a stationery, and then the rest is designed and produced. Here also the life cycle of a butterfly. We fixed these into a board because if you don't fix, students are not able to follow the cycle. But we also have given more of those materials to them to play with first, and then to understand what kind of structure they have. And then we give the second one, which is on the fixed board one, in which can they follow the cycle, and then they can read it. These are also printed in Braille too. We also developed some kind of heat transfer activities. These are that normal experimentation activities, but they used infrared thermometer, talking thermometer to measure the temperatures and then see the heat transfer effect with the different materials. And but we fixed those glasses and then the boxes onto the board that to prevent the spillage of the hot water. So there are different materials that you can see here from all areas of the science, and there are more materials here. This is the human development system, and what we did all of in this one, we adapted materials for the sighted students, which is used for the sighted students. We used everyday materials to develop instructional materials, but everyday materials are cheap but easily available but not durable. There are some disadvantages in terms of using everyday materials. But we used also 3D printing technology, but the 3D printing technology is expensive, not available everywhere else, but it is durable also. It is very good. I will just summarize with the results. What was the result? The motivation and interest towards science was increased dramatically, and the students developed positive attitudes, students developed practical work skills, and they start learning, understanding, and the learning and understanding is also improved quite a lot because we interviewed for them. There were some drawbacks. Time management was difficult due to the too much time devoted to understanding the materials. And then students' lack of scientific process skills was a problematic one. And writing reports was also difficult for them because they didn't have any kind of experience on this one. And during the COVID-19 pandemic, one of the most difficult problem was the access of the internet, and the screen reading was a problem. And heavy workload from the home was really difficult because the families has no experience for this one. And access to the printed tactile materials was a problem. Visual measurement and evaluation is really challenging. And also school closures created inequality between the students with mostly disadvantaged groups. There are some of the papers which came out of this study in English. You can see these papers, and I would like to thank for the Changpa 2020 organizing committee again, and thank you for your participation. And I would like to thank for the funder of this project and students and the teachers. And I would like to thank to my project team. And I would like to finish here with my email. And then I'm happy to answer your questions at any time with my via the email, and also I would be happy to answer during the live discussion. And thank you very much for your interest. I'm stopping here. See you on the live discussion.